Okay. Still with chapter 15, with a new kind of example, which is you have to deal the situation with a charge that can be formed like a triangle. Okay, it can also be formed like a square or maybe an equilateral triangle. But today, um, for the last example in chapter 15, I would like to show you a different kind of example from the example 1, which is the right angle triangle punya contoh. Okay, for the charges. Okay, so let's see. This is 4 meter apart and this is 3 meter apart from the charge one. Okay, so we can form a Pythagoras theorem with the green line, which is 5 meter here automatically, because we already knew that this is going to be the 4 meter and 3 meter based on the coordinates given. Okay, this is going to be sorry for that, 4 3, yeah, 4 3. So if you are given a coordinate in the equation, you can also form the distance. You can get the information of the distance between the charges. Okay, so this is charge 1, charge 2, and charge 3. I name it just like that. Okay, not with the alphabetical name, so just a numeric. Okay, so if the question asks you to find for the magnitude and what is the direction of the force exerted on the charge 3. Okay, so bila kita ditanya dengan soalan macam ni, it means that you have to find for the net force on charge 3. It means that daya sebesar-besarnya dekat 3 tu. Apa maksud dia? Okay, daya sebesar-besar ni selalunya maksud dia mesti ada more than one force that is exerted, yang mempengaruhi, yang that influence in that charge, which is as we can see here as the example. Okay, charge 3 is the positive charge. Selain dia tertolak ke sini, okay, this way, right? So sort of because of the repulsion, because of the same sign of charges, based on the properties that I have told you before. Okay, it will be repelled to this way. So the name for this repulsion, or the force of the repulsion, is we call it as the force that is exerted by charge 1, yeah, charge 1 on charge 3. Charge 1 ni lah yang menyebabkan dia ke sini. Charge 1 ni menyebabkan charge 3 ni tertolak ke sini. So force exerted, penyebab dia exerted by charge 1 on charge 3, kepada charge 3. Okay, so this is one of the force that mengganggu charge tu, yang tolak charge tu. But there is another force yang mengganggu charge tu. Bukan mengganggu dia, let's say like dia tolak, dia kacau, sort of like that lah. Okay, so another force is going to be in this way, which is the name for this force is attraction to, okay, force exerted by charge 2 on charge 3. Okay, selain dia tertolak oleh charge 1 ni, dia juga tertarik ke sini oleh charge 2 ni, sebab dia berlaku attraction, positive and negative, berlaku attraction. So selain dia tertarik ke sini, dia juga dia tertolak ke sini, dia juga tertarik ke sini. So where the net force on charge 3 will be, finally end up ke mana dia akan pergi. Okay, so itulah kita namakan F net, which is the net force, daya sebesar-besarnya. Selepas dia dah tertolak ke sini, ke tertarik ke sini, akhirnya dia akan ke mana. Okay, let's say dia akan ke sini. Kita tahulah bila sini satu dia berlaku resultants, right? So it may be around this angle lah kan. So let's say it will be like right here. Okay. So akhirnya setelah dia ada daya yang tolak ke sini, ada daya yang tolak ke sini, akhirnya dia maksudnya pergi ke sini. Faham tak? Okay. So how are we going to calculate it? I will advise you to do this kind of method, which is table. Okay. Ini kita draw kat sini So because we don't have enough space. Okay, so I will advise you to do this kind of method so it will be much more proper. It will senang dinampak. Okay, so this is going to be the name of the force. This is going to be the component of that force, component x component and y component. Okay. So what we have is F13 and F23. So let us start it with the one and only component that it have, which is F23. It only have X component, right? So F23 with the formula of K, Q1, Q1, Q2, R square. This is for the force. Okay? Coulomb's law. Okay. So just substitute all of them. And this is what you will get. Okay. I just want to remind you that this formula is included with the modulus, so just ignore the negative sign because modulus of negative will be positive end up. Okay, so this is negative charge. It means that this is negative charge also. Okay, so negative 2 times 10 to the power of negative 9. But you don't have to include the negative because we have modulus it already. So, and then the distance between the charge 2 and 3 is 4 meter. It is already in SI unit, which is in meter. So just 4 square. Okay. And the answer is... So the answer is 5.62 times 10 to the power of negative 9. But before I forget, let me remind you another thing. Because as a previous video, I already show you about the directions. Okay, the directions, if it is going to the left, it will be negative. If it is going to the right, it will be positive. If it is going to downward, it will be negative, and if it is upward, it will be positive. Okay, let me draw it for you. Positive, positive, negative, negative. Okay, it is in a number line as well. Okay, so this is going to be negative because force is a vector quantity. When it is a vector quantity, it has direction. So this is just the magnitude with the unit, Newton. This is just the magnitude. But we have to include with the direction as well because force is vector quantity. Okay, so negative. You have to include it. So there is no y component in force 2, 3. No y component, right? It's only with the x component. So just 0, 10. So let me make it nice to see. Just put the value because we don't have enough space. Negative 5.62 times 10 to the power of negative 9 Newton. This is 0. And that's it. Now we are going to find for the F, what is the name? F13. Okay, F13. So with the same kind of calculation. Okay, kat sini ada benda lain sikit because let me find for another color. Okay, it's okay. I'll just use the red pen so you can really see what I meant. Okay, sini adalah X component dia. So we call it as F13X. Okay, and this is going to be the F13Y. And we are searching for this one for F13. Kalau kita buat satu-satu lah. Tapi sekarang ni kita buat gabungkan terus dua force yang berbeza, kita gabungkan terus, nanti kita campur X component dia, end up kita dapat apa, X component dia, end up Y component dia, total up, kita dapat apa, and then we just gonna use the this formula which is to find for the resultants punya yang orange tadi kita tunjuk tu, which is dia akan pergi ke sini satu, pergi ke sini satu, so end up mungkin dia akan pergi ke sini ke sini ke, yang dot ni stand for this one, the I don't know how to call this name, the resultant force. The resultant force. So to find for the resultant force, or we call it as the net force, just use the formula that has been usually used nowadays, and not nowadays. Yang memang dah selalu guna. Okay, so yang warna merah ni kan, X component, right? This is in the X component. So kalau X component, there is the reasons, but I'm not going to explain in this video. Maybe just remember je lah apa tu, kalau in X component, if the angle is dekat sini, kat bahagian sini angle tu, so it will be cos, and then yang dekat tempat yang tak ada angle tu sin. Just remember that thing lah, because I'm not going to explain it in this video. Okay, so we have to include with the cos. What is the angle? Okay, we have to know the angle in order to complete this working step. But before that, let us complete the things that we already have, which is the 1 and 3, the distance between the charge 1 and 3. 1 and 3 do not look at the other distance of charge. So 1 and 3 is 5 meter. So 5 square. So how are we going to find for the angle? Based on the formula in calculus. Okay. So let's say this is theta. We name it as theta. And this already known as 90 degree, right? So sine 90 degree opposites to 5 meter. Okay. And sine theta opposite with 3 meter. Ni akan jadi sama kan? Benda ni sama. Okay. Ni sama, and then bertentang, so 3. So the theta is going to be 36.9 degree. Okay. So we are going to use this angle, this place, 1 degree. And the answer is 8.64 times 10 to the power of negative 9 Newton. And it is positive because it direct on this way, okay, at the right side. Okay, positive. just not to make you confused itself. And then with the same kind of step, which is just put in k is 8.99 times 10 to the power of 9, because I don't have enough space, so I just put the symbol, and you can also get it in the calculator if I'm not mistaken, with the constant value. And then for the y component, with the same step, but you only have to change for the sign. Okay, change it for its sign for the y component. Okay, for y component, because I don't have enough space to write it. So if it is for the y component, the answer that you will get is 6.48 times 10 to the power of negative 9, with the same sign positive, because it is direct upwards. Okay, it is in a positive direction. Okay, upwards. And then, okay, let me put it all together. So the answer for x component for force 13 is positive 8.64 times 10 to the power of negative 9, and 6.48 times 10 to the power of negative 9 for the y component. So what are we going to get here is, what are we seeking for is, okay, actually bila kita dah dapat x component, y component, sebenarnya kita boleh buat dia secara asing-asingan. Kita dah dapat resultants yang ni, kita dah dapat resultants yang ni, and then dapatkan resultant baru. So it is very complicated, right? So I really advise you to do in the table form, so it will make you easier. Okay, so y component, x component and y component, just plus it, and you will get 3.02 times 10 to the power of negative 9. What you will get is positive. Okay, this is bigger than this one, so it will be minus. Okay, so you will get positive direction, and this is automatically 6.48 because you've plus with the zero number. Okay, positive and positive. Okay, and then for the resultants, or we call it as the net force on chart 3, will be this x component square kan dia plus with that y component square kan dia. Okay, so positive 3.02. If it is negative, just put it negative lah, but end up dia akan just perform like a positive number because it is squared. Okay, bila dia digandakan, negative with negative will also be positive, right? So just put the magnitude is already enough. Okay, 3.02 times 10 to the power of negative 9 square plus with 6.48 times 10 to the power of negative 9 square as well. So the answer that you get is 7.15 times 10 to the power of negative 9. So this is the magnitude, ukuran dia. Okay, ukuran value force tu, daya dia, ukuran daya dia adalah sebanyak ni. Measurement daya dia tu, macam tu, reading, that word I mean. Okay, reading bagi that daya, that force is this one. But what is the direction? Where is the direction of the net force on chart 3 will be? So kita tengok kat sini. Okay, ni dia punya force I just erase it. Satu, dia akan direct positive x direction, right? Positive x, positive y. Okay. I would rather use this kind of method rather than with just forget what I mean. Positive and positive, so it will be always a reference to the x component. So north east, it will be north of east. Okay, north of east. Tapi nak dapatkan dia punya angle tu tan -1. This is the angle. So angle is tan -1 y punya, y over x, sebab kita nak dapat angle pada reference to the x component. Kita tak nak angle dekat sini, kita nak angle yang dekat x component, so we put it as y divided by x. Okay, so y divided by x is 6.48. This one 6 point, I don't have enough space lah. 6.48 times 10 to the power -9 divided by 3.02 times 10 to the power -9, and end out you will get 65 degree. Okay, so please put it as 65 degree north of east, seperti yang telah dinyatakan tadi. Okay, thank you. That's all.